Haircut. Woohoo! Flannel. Woohoo! It's almost June for crying out loud. It's cold out there. All right. This week, we meet one time. Or I should say that, if I say we meet, that means if we were actually together, which is not supposed to be an online course, then we would be meeting once this week. And the last week of May. And we would be doing the topics that you would see. Go and get your topic sheet from Essential Course Documents. Go, 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 go. Okay, got them? Good. And you would see that it says average atomic mass, review naming. Average atomic mass is what we've got to do this week. This is going to wrap up the first unit, the first section that you will be assessed on. I know, it's rocking and rolling, huh? Time flies when you're having PHUN fun. All right, so I'm not going to review naming and formula writing. If you want to review that, you can just go and look at the videos again, because I have the videos. Average atomic mass, second thing on that list. I've gone over that. I've talked about that. We talked about average atomic mass when we talked about isotopes. Okay, there are different forms of the same element, isotopes. Hydrogen has good old high quality made in America hydrogen, deuterium and tritium. There's carbon 12, 13, 14. All right, these elements, different kinds of the same element. So isotopes due to different amounts of neutrons. So if I'm tritium, I have one proton, which makes me hydrogen. I'm a form of hydrogen, so I have one proton. I'm hydrogen. No matter how many neutrons I have, the protons determine who we are as elements. So if I'm tritium, I have one proton, but I have two neutrons, as opposed to deuterium, which has one proton and one neutron, as opposed to hydrogen, which they're all forms of hydrogen, but hydrogen, one proton, zero neutrons. So the average atomic mass, if you look on the periodic table, you're not going to see whole numbers. You see decimals. With hydrogen, it's 1.00797. Well, why is it not a whole number if protons and neutrons are given a relative mass of 1 and an electron a relative mass of 0? We should just get whole numbers on the periodic table for masses, but we don't, because the average, the weighted average, weighted average means that we consider what percent these isotopes occur in nature and do an average based on the percentage they occur. So vast majority of hydrogen is hydrogen. A little bit of deuterium and a tiny bit of tritium, average the 3, and we get an average mass of a little bit more than 1. Okay, so that's average atomic mass. We are going to round those to whole numbers when we do our math on the board with stoichiometry or percent composition, which we're doing today. So we're going to use average, the rounded masses from the averages. Okay, you will see that we have the mole, and the mole gets 2 stars. Okay, if you get 2 stars, you're pretty important. The mole, I always tell my Chem 1 students, if there's anything you're going to remember from Chem 1, doggone it, remember the mole. If you have to do chemistry beyond, chemistry 2, and even chemistry 2, I said, remember the mole, and we did remember. You need to know what the mole is and how to convert moles to grams, grams to moles. You need to know that, people. You just gotta. The mole. Okay. I always like to use the analogy when I'm talking about introducing the mole. You probably have heard this one, but maybe not, that a mole is a number that represents, it's a word that represents a number. So the word mole represents an amount of something. Remember, in the international system, the amount is the mole. The amount of matter is the mole. That's not mass. Remember, we went over that. Mass is not the amount of matter. No, it's different. Okay. So the amount of something represented by a mole, the word represents a certain value, just like the word dozen represents 12. And if I said, yo, Angsty Billy, could you go down to Dunkin' Donuts and pick the class up some donuts? How many? 3 dozen. Okay, Billy knows how many donuts 3 dozen are. He knows, and so do you, that's 36, because we know 12 per dozen. A half dozen would be 6. So we know that. That's a word that represents a number. So occasionally we get those in science. A word represents a number value. A dozen represents 12. A mole represents a lot more than a dozen. Okay, a mole represents this number. 6.02 times 10 to the 23rd of something, of anything. Now, of course, if you want a dozen donuts, you get 12 donuts. But you couldn't have a dozen loaves of bread and get 12 loaves of bread. A dozen meter sticks would be 12 meter sticks. So it represents a number no matter what you attach it to. You can have a dozen of anything you want. You can have a mole of anything you want as well. Although most things that you and I deal with on a daily basis, you would not want a mole of it. Yes, I would. I would want a mole of pennies. A mole of pennies. That would be a lot, wouldn't it? Oh, it sure would. Yeah, I can put that in a bank. Oh, no, you could not. You could not put a mole of pennies in a bank. Now, you know that a penny is not very big, okay? Yay big. You would not want a mole of those. You would be in trouble. Big trouble. You'd be in big trouble, mister. Okay? Michelle, full house, with me. Michelle, little cute. They're twins, actually. Now they're super rich. Where was I? Big trouble, mister. Oh, yeah. Because if you had a mole of pennies, you would have, you ready for this? And I have actually done this calculation. I'm making this up. I've actually done the calculation of the volume of a penny, I know the radius of the earth, the circumference of the earth, 50 feet. Okay. You would have the entire planet Earth covered in pennies, 50 feet deep. Yeah, let that sink in. So you would not want a mole of pennies. Imagine that the room that you're sitting in here in watching this, unless you're watching this outside, I suppose you could be. Probably in a room, though. Look at the room. Look around you. And imagine the room, just that room filled with pennies. That's just an unimaginable amount of pennies just filling a room. Oh, we're not talking about a room, people. We're not talking about a whole house. We're not talking about a city. We're talking about not even a country. We're talking about the whole planet 50 feet deep in pennies. That's how many pennies you would have, which is completely, our brains cannot handle that amount. We can't imagine that. Here's one more for you then. Here's another, a mole. How to mole a piece of paper? Piece of paper, really thin. Okay, that's nothing, right? That's nothing. So what if I had a mole of paper? Piece of sheets of paper. That would be okay, right? I suppose. But the stack of paper would go from Earth past the moon. Okay, you would have a stack of paper that you could climb. Okay, but it wouldn't tip over. You can climb past the moon on that bed, Larry. That's how much paper you would have. So a mole is an enormously unimaginable amount. In fact, if we were to write this out, 602, there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 20. Am I even in the thing? I don't know. Maybe. Just barely. Let's see. Boom. Yeah, okay. Boom, 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 boom. It's just like, here's 1,000, here's 1,000,000. Here's 1 billion, here's 1 trillion, here's a holy crap. It's big, okay? Now I make my point, it's big. Now you might be saying to yourself, I'll take a dozen donuts. I would not want to take a mole of donuts. That'd be a lot of donuts. How high would the earth be covered with donuts? Donuts, so good and so good for you. What's the reason? Why would we want this huge number? By the way, this number actually has a name. It's called Avogadro. Okay, you know avocados, little fruit, avocado. Yeah, that guy, Avogadro. Okay, you spell avocado. Okay, it's not avocado. It's Avogadro. Avogadro's number, who determined what this number is back in the late 1800s. Avogadro. Avogadro. Good Irishman. Avogadro's number is used because we have to measure some measurable amount of things that are really, really tiny, which of course is the atom. Atoms are so small. Remember we talked about an atom and the space between it with the gold foil experiment, that even something is as dense as gold is mostly empty space. So atoms are super, super unimaginably small. We can't even imagine how small they are. Then you're going to need a butt ton. Man, a mole's a butt ton. Okay, it's very scientific. A butt ton of them to measure any amount. In fact, if I wanted you to go measure me a mole of carbon, some of you might know how to do this, some of you might not remember, but we'll know soon. Then you would go back to the balance and you would mass out 12 grams of carbon. So a mole of carbon atoms would only be 12 grams. 12 grams isn't very much. It takes 454 grams to equal a pound. So 12 grams isn't a lot, not very much mass. And you would need a mole of it, that many particles. And remember, a whole particle, a mole of pennies would cover the earth. So that you just imagine what that means for how small atoms are. Okay, so the mole is a word that represents a huge amount. And we need that huge amount because atoms are so darn small. All right, now, if we look, next we have molar mass. I put molar mass on here. And molar mass means the mass of a mole of something, molar mass. So what we're going to do is get our periodic table. Get yourself a periodic table. I've got 2 loaded in, and if you have the chemistry book, there's a couple of them in there, one on the cover. Open up the cover. And we're going to start using this bad Larry because we are going to get the masses of compounds and then what's called percent composition. We're going to do that today in this video. So if I want to get the mass of something, I use my periodic table. Now you're going to notice that the mass of anything on here is hydrogen. Okay, you're going to notice the mass of the hydrogen does not have, water break. Does not have a unit. It just gives you the number value. There's no unit here, no kilograms, no grams, no megagrams or micrograms, nothing. It's just a number. Why does it do that? 1.00794, and then nothing. The reason is because there are 2 ways to express mass from the periodic table. 2 ways, all right? First way is called AMU. Amu, AMU, amu. Amu's the sound a cow makes. Amu is the sound a cow makes, moo. Now, this stands for atomic mass units. Atomic mass units. We've talked about those already in this video. The given atomic mass unit for a proton or neutron is 1. Okay? The given atomic mass unit for an electron is 0. Remember, it says mass unit, so electron has no mass. Protons and neutrons get a mass unit of 1. So atomic mass units is the total amount of protons and neutrons. Those are the mass units. And we add those up and we get some value for what's called atomic mass. And since those are units that are just given as assigned numbers, they don't have there's no grams or micrograms. It's not Corona. Don't worry. I've been talking too much today. I made 6 other videos, and my throat's getting a little. Cut it out. No. All right. So atomic mass units don't have a grams associated with it because you're just adding up what are given relative masses. Okay, now the second way to look at a value for a mass on the periodic table is AMU. So guess what? My second way is grams. So if we have a mole of it, grams if moles. What do you mean by grams if moles? If I have a mole of carbon or a mole of hydrogen, then we would give that mass number the number of grams. All right? So if I said, what is the mass of carbon? You should say, well, what do you mean? Are you talking about like one particle of carbon? Like 1 atom of carbon? Is that what you're talking about? Or are you talking about a mole of carbon? Very good. That is how you should respond to that question. What's the mass of carbon? So the mass of carbon, if we look on here, okay, carbon, is 12.011. Of course, that's the average atomic mass with all the isotopes. Throw it in there. That would be 12.011 atomic mass units if I were talking about 1 atom of carbon. one atom of carbon gets an atomic mass unit of 12.011. If I'm talking about a mole of it, it would be grams, right? 12.011 grams. All right, so atomic mass versus grams. Are we talking about one or a mole? Okay, this video is 15 minutes. We'll stop here, pick it up on the flip side, how to get masses of compounds. Woohoo!